Generative AI refers to advanced computer systems capable of creating new content, such as text, images, and even music. Well-known examples include tools like Chat and AI-powered image generators. These systems are designed to learn from vast amounts of data and produce outputs that often mimic human creativity. Their ability to generate original material has rapidly transformed fields like communication, art, and business. Let's pause for a moment and consider a thought-provoking question. What is the hidden cost of making AI work? This immense energy demand often goes unnoticed by end users because the computation happens in remote data centers. Servers generate a tremendous amount of heat, and water is commonly used to keep them from overheating. As AI models become larger and more complex, companies must regularly replace or upgrade their server equipment to keep up with performance demands. Which part do you think uses the most resources, training, running, or upgrading AI? Take a moment to ponder or tap your guess. This question encourages us to think critically about where the major environmental costs actually lie within the AI life cycle. Reflecting on your answer may reveal surprising insights about the true footprint of these technologies. On one hand, AI can help us predict weather patterns, model climate change, and develop environmental solutions, which is a clear societal benefit. On the other hand, the energy required to run these models can be significant, potentially offsetting some of the sustainability gains. This real-world example illustrates the complex balance between leveraging AI for good and managing its associated environmental costs. Old hardware, if not properly recycled, can contribute to growing e-waste problems, leaking toxic substances into the environment. Think about ways you might minimize the ecological impact of your digital projects, perhaps by optimizing code, supporting energy-efficient infrastructure, or advocating for sustainable practices within your organization. Every action, no matter how small, contributes to a larger culture of digital stewardship. By being mindful of both progress and sustainability, you help pave the way for smarter, greener technologies. Transparency in reporting could drive more sustainable practices and inform consumers about the true cost of the digital services they use. Every digital action, from asking a chatbot a question to generating an image, leaves an environmental footprint. Being aware of these costs helps us make informed decisions about when and how to use such technologies. Our collective choices can influence how AI evolves in the future. It also raises important questions about accountability and regulation in the tech industry. Considering this prompts us to think about the standards we want to set for responsible AI use moving forward. AI powers advancements in healthcare, education, and accessibility. But the resources it consumes are substantial. Digital responsibility means making conscious choices about how we design, use, and support technology, always considering its social and environmental impact. By considering both the positives and the ethical challenges, we can help ensure that AI development aligns with our values and priorities. Asking tough questions and demanding transparency encourages more responsible innovation. This approach positions us to lead by example and advocate for a more sustainable digital future. It invites businesses, developers, and users alike to weigh the long-term effects of their digital decisions. Adopting a mindset of responsibility ensures that our pursuit of technological advancement aligns with broader goals of sustainability. This trade-off invites us to reflect on whether the benefits outweigh the environmental price we pay. As a society, We must grapple with how to encourage progress without compromising our planet's well-being. This cycle of constant hardware refreshes compounds the overall ecological cost of AI technology. In regions facing water scarcity, this demand can place additional stress on local resources, raising concerns about sustainability. Water usage is an often overlooked aspect of AI's environmental impact, but is increasingly recognized by experts as a critical issue. Such statistics highlight the scale of operations behind popular AI tools, underscoring a need for greater transparency and awareness. As AI adoption increases, so does its collective energy footprint. While many of us marvel at AI's capabilities, we rarely think about the resources it requires behind the scenes. Just as a car needs fuel to run, AI demands significant energy and infrastructure to function. Training an AI involves processing vast datasets, which requires data centers filled with powerful servers operating nonstop for days or even weeks. These data centers use significant amounts of electricity, not only to run the servers, but also to maintain their optimal performance. Once trained, running the what we call inference also consumes substantial energy, especially when millions of users access the model simultaneously. This question invites us to look beyond the surface and examine what it truly takes to power these intelligent tools. It's important to recognize that every digital tool, including AI, leaves a mark on the real world. Although software and algorithms may seem intangible, the servers, networks, and devices that support them are physical and consume resources. Each time we interact with AI, we trigger a series of processes that use electricity, water, and computer hardware. Understanding this connection helps us appreciate that our digital actions have tangible environmental consequences. AI models, especially the large ones, demand enormous computing power to both train and run. To put things in perspective, here is a striking fact. Training a single state-of-the-art AI model can consume as much electricity as several average U.S. households use in an entire year. Beyond electricity, massive data centers also require vast quantities of water for cooling. Another factor to consider is the electronic waste generated from frequent hardware upgrades. Now, let us involve you in the conversation with a quick interactive poll. We are faced with a significant ethical dilemma. While AI brings remarkable innovation and convenience, it does so at a notable environmental cost. This is where the idea of digital responsibility comes into play. Consider, for example, the use of AI in climate modeling. Here is a question to reflect on: should companies be required to report the environmental impact of their AI? In summary, generative AI offers impressive capabilities and transformative benefits, but it's vital to recognize the environmental trade-offs involved. It's essential to remain critical and thoughtful when engaging with AI, whether as users, developers, or policymakers. As future leaders and creators, you have a pivotal role in shaping the balance between innovation and environmental responsibility.